Hello, I'm going to do the following exercise for you. So it says, the weights of players in a sports league are normally distributed, and that you have to pay attention to. It says normally distributed, you know what that means. It's a normal distribution exercise with a mean of 76.6 kilograms. Correct to three significant figures. It is shown that 80% of the players have weights between 68 and 82 kilograms, and the probability that a player weighs less than 68 kilograms is 0.05. Find the probability that a player weighs more than 82 kilograms. Well, if we do a little drawing for this, let's see how good a drawing I can make today. Our 76.6 is going to be the mean, so it's going to be somewhere around here. Great. And we know that less than 68 is 0.05. This is 68 here. Between 68 and 82, let's put 82 somewhere around here, why not? We know that this area is going to be 0.8, 80%. All this area here. So what it's asking us is what this area is, and it's not difficult because it's 1 minus 0.8. Because all the area under the curve is going to be 1. Therefore, if I just subtract this and this, I'm going to get the final answer, which is going to be 0.15. Now for part B. The standardized value for 68 kilograms, what this means is that there's a value in the standard normal distribution that has the same area to its left than 68. 68 has 0.05. What is the value Z here that has its area to the left of it is 0.05. So I just go to my calculator and I put inv norm and I'm going to get it. Inv norm 0.05, comma 0, comma 1 minus 1.64. And that's my standardized value. That's the same value as 68 in the normal distribution that has the same area that 68 has before that value. So here is 0.05, so here there's a value Z, which happens to be minus 1.64, that also has 0.05 to its left. And hence, find the standard deviation of weight. Well, what we know about this minus 1.64 is that also happens to be the z-score of 68 in this normal distribution. Therefore, minus 1.64 is equal to 68 minus the mean, 76.6, divided by the standard deviation. If I solve this, I'm going to get the standard deviation, which happens to be which happens to be 5.24. And so I've done the next part too. Moving on, let's go to part C. To take a part in the tournament, a player's weight must be within 1.5 standard deviations of the mean. So, what does that mean? That means that there's a value that has a z-score minus 1.5 over here, and one that has 1.5 over here, and I have to find them. And they're going to determine my interval. I don't know exactly what they are. They don't necessarily have to be these ones. Don't get confused. They could be close to those ones, but they don't necessarily have to be those ones at all. So, let's do it. How do we do it? Well, we know that it's 1.5 z-scores away. So if I just put this into 6.6, remember that's my mean divided by the 5.24 I just figured out, I can get the value of x. Let's call this one x2. I can calculate the value of this one. And if I do it for the other side, I just have to put minus 1.5. Let's put x1 here. You'll see why in a minute. Look a bit better. And if I solve these equations, what I'm going to get is, let me do this carefully, 5.24 times 1.5, okay, plus 76.6. This is going to be 84.46. 84.46. Excuse the iPad, it has its limitations, I'm afraid. And this is minus 1.5 times 5.24. Oops, I put 25. plus 76.6, and that's going to give me 68.74. And that's my interval. 68.74 to 84.46. And that's what I'm looking for. Great. So now to part 2. This is easy, because all it means is a player takes tournament, find the probability that the player takes part in the tournament. All it means is what is the area between these two values, right? So this one's already wants to participate in the tournament. Let's make it in a different color here, which is green for this one. So we know that there's a value here, 68.74 up to 84.46. So maybe this 82 was not very well drawn, huh? Because these are the same distance from the mean. But there's some values here, right? And it's asking us, what is the area of this part of the curve? So all I have to do is go to my calculator, just put this in normal CDF. So normal CDF, 68.74, 84.46, mean 17.6, standard deviation 5.24. Off we go. What do we get? 0.866. All I did is just go to my calculator, put normal CDF, and I just put these values lower bound, this values upper bound, then I put the mean, and then I put the standard deviation. And that's what I got. I'm going to write it again. It's terrible handwriting right now. 0.866. Okay, fantastic. Great. So finally we're in part D. Let's do part D now. Of the players in the league, 25% are women. Of the women, 70% take part in the tournament. Given that a player selected at random takes part in the tournament, find the probability that the selected player is a woman. So, 25% of the players in the league are women. So we have 25 over here, 0.25 over here. Let's make a little T-diagram. I encourage doing these always when you read these things to make sure you know what they're asking. And of these 0.25, 70% take part in the tournament. 0.7 take part in the tournament. Great. Given that a player selected at random takes part in the tournament, okay. So let's find this. This is a woman, and take part in the tournament is, let's put a P and 0.3. P for participates, and not P, okay? So given that a player takes part in the tournament, so given that find the participating player is a woman, this is what they're asking for. Remember what this means. Given that a player takes part, participates in the tournament, so knowing that this, find the probability selected player is a woman. And this is going to be equal to, remember the formula, probability of a woman intersection participates in the tournament divided by probability of participates in the tournament. We'll continue on this side here. I'm running out of iPad here. So that's going to be equal to this part here. We can easily figure it out in the tree diagram. 0.25 times 0.7. 0.25 times 0.7 divided by, and the probability that participates in the tournament is what we calculated previously, at 0.866. And this is going to be equal to divided by 0.866. That's going to be equal to 0.20. 0.2. And that is the end of the exercise. Now, I took 9 minutes 15 seconds to finish this exercise. Keep in mind it's 15 marks. So actually, for this exercise, roughly, you had about 15 minutes. So if you do it at this speed, you're doing fantastic time in the exam. However, remember that some exercises will actually take a little longer and some exercises will take a little less. It's not a bad time. Well, thank you very much for watching. Bye-bye.